Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes. This video is brought to you by RV Glassbox, the quickest way to apply section boxes to all your classes in Navisworks. Get your free copy today using the link in this video description. Have you ever wanted to mark the location of classes you found in Navisworks right here in Revit? For example, using these spheres where you can select them, see the class name from Navisworks, and instantly understand where they are in the model. Well, I will show you today how to do this super quickly using Dynamo. This is what we will create together. For example, I will delete these spheres for now. Go back to Dynamo. Make sure we have the class reports from Navisworks selected here and run the script. And just after 1 second, I have all those class markers automatically generated for me. For example, let's pick one of them. Maybe this one here at the end. This is class 1. When I go back to the Navisworks model for this project, when I go to the test, go to result, select class 1. That's the same class we are seeing now in Revit. To double check this, I can also go to Revit again, back to Dynamo, and then use another script we have for writing XYZ coordinates to the object. In this case, I have the X, Y, and Z parameters for this marker, but they are empty for now. Let's run this. And now you have their coordinates filled in automatically. If I now return to Excel, and then check out class number 1, this one here on the top row, I can see straight away these are the same coordinates, so the whole thing works. So if you want to try these two scripts yourself, but don't have much time to review them with me, just go down to this video description and use the link there to download these scripts, as well as the sphere family for the marker there. If you, however, want to understand how to build a script and how it works, let me show you now exactly step by step. By the way, if you are new to this channel, make sure to subscribe now, because we do tutorials like this every single week. Okay, let's begin. We have here the same Revit model from before, which contains MEP elements like ducts and pipes here, along with architectural walls. So now let's see those clashes between ducts, for example, and walls in Navisworks. If I open Navisworks now, you will see the same model in here, and these are the same objects. Let's now run a class test. Let's go to Class Detective. I have set up class 1 already, and this one will class all the ducts to all the walls. Of course, I exported the walls separately. That's why you see here all the walls are in this one single NWC, and all the MEP elements are in the other NWC up here. Alright, let's run this test. And you can see now it has produced 45 clashes for us. Let's see them in the context of this model. So we have here one of them, another one here, another one there. Now let's see those clashes in Revit. Firstly, you need to export from Navisworks the class report. So let's make sure you select the right class test there and go to report. Now choose the format to be HTML tabular. And in this case, I will export the current test, but feel free to do more, like all tests there if you have time for it. For now, let's do one. Let's choose write report. And you have seen I've done a few tests there already. Let's call this one test number 3 and save it here. Okay, that was quick. I will now open the report in Excel. If you haven't opened Excel yet, now is a good time to do it. Just open a blank spreadsheet like this, and then go to the folder that we exported the report to, select it, and drag it into Excel. So even though that's an HTML file, Excel can just read it just fine. In here, there are a lot of information, but for now we just care about two things. Firstly, the coordinates in X, Y, and Z of the class points, and also the class name, because in Revit, this will help us identify the Navisworks class later on easier. Make sure you know the unit of these coordinates values. For example, if I go back to Navisworks quickly, as you can see this model here, when I go to Options, Model, or actually Interface, I can select the display unit, and that's now showing as millimeters. So that's how I know these coordinates should be in millimeters as well. All right, let's open Dynamo and start scripting. I will go back to Revit. Open up Dynamo here already. I've done that for you. Let's now make a new definition. Firstly, of course, change the run mode to manual. And now we can start doing some first notes. Let's start by bringing in the information from Excel. So I would try for file path. Click here, select the Excel file on the window, and then open it. Moving on, we can do a file from path. Connect to here to get the file. And then, of course, we should do read Excel or import Excel. Get the file to there. It needs to have a sheet name as an input. So let's see what should we give it. In this case, I will just copy this text down there, which is test3. Go here, define that as a string, and connect it to sheet name. We can now run this. And very quickly, you can see now we have all the information from Excel. But that's a lot of noise, so let's filter out just for the coordinates and the class names. We can do get item at index without a space. The data will be going to list, and now we need to know the index of the column for coordinates. Super easy. I normally do this. Just go to Excel and maybe type in a few numbers starting from 0, 1, 2. I can now drag this over just so I get the right column indexes. So now as we can see, this column here for class point coordinates is at index 9. Let's open here, back to Dynamo, and define the column index like this. When I run this, you will see the index has given me all these coordinates values. Or is it? We actually forgot one step. We should go to list here and use levels. Let's try with level 2. Okay, now that's more like it. We have coordinates back. However, these are not only coordinates. We also have in here empty cells and cells for titles or text. Let's filter them out. Firstly, let's clean up the no values. So let's do is no. Get them to here. And then we do a Boolean mask like this. Connect to there. And then use the mask to filter out for the coordinates only. If I expand this, you will see the in list is what we don't need because these are nodes. We need values from the out list. However, in the out list, I still have text. So let's remove them as well. Let's do string.start with. Get the out values to string. And now we need to search for the prefix we want the valid strings to have. In this case, the prefix will be x and then colon, because that will begin a valid coordinate string. So I can now do x colon, search for that text here, and run it. Now we have a list of trues and falses. Let's do another Boolean mask here. Connect the out list to list and use this new mask. Run this again. And you can see now in the in list, that's exactly what we need, all the coordinates as string. And we can now discard the out list, so everything works to this point. Next thing to get from Excel will be the list of class names. So going back to here, we need to get the class names from here. Let's do another get item at index. Paste them to here. And what's the index of the class name column? Let's check. That will be index 2. So we know what to do now. Change the number here to 2. Run this. And yes, these are class names. Now we need to filter this list using the same Boolean mask up here that we did for the coordinates. Super easy. I can just copy this node down. Change the list of input items. Run it. And now we have all the no values filtered out for us. Let's now do the second mask here. Copy this down. And use the out list, just like what we have up there. Use the out list, not in. And now if I run this, I will get all the class names that are valid. For now, I will just turn off the background grid there. That bothers me a little. Let's move it down here so I don't see it anymore. And now we're good to go. The next step is to obtain the individual x, y, and z coordinates from this string. We know they are the right data, but they are not yet of the right format. So let's change that. Let's firstly do toNumber. So we are converting here all those strings to numbers, like this. Actually, before doing that, we need to split it first. So let's do string.split. Okay. Now for the separator, we can define 3 of them. So let's do additional inputs. And now the first separator will be x. Next one is y. And then we have z, all followed by the colon. And now that will be separator 1, 0, and 2. Let's see what we get. Okay, that looks fine. We can now have x, y, and z for each class. Even though they still have the comma at the end of the coordinates, let's change that. Let's add the comma here and the comma there. Try this again. Now that looks good. It's time for us now to convert these strings to numbers. Let's see if that succeeds. Yes, it does. Now we have all these numbers looking very similar to the strings, but now they are of the right data type. Next step, we don't want to create the class markers individually, so let's transpose this list. Let's do transpose, like so. And then you will see what it does. It collects all the x values from these sublists into the first item here, which is list 1 for x values. Then you have the same for y values in the second list. And then the last list is for the z values. So that's really good. Now I want to explode these 3 lists into individual inputs to my next node. So let's do a quick code block here. So let's say x is a at index 0, y is list a at index 1, and z will be also list a but at index 2. Just a way for us to get the x, y, and z lists as individual items. So now I have preview here just the z list, but we know that x and y have also worked. Alright, moving on, we need to ensure one thing exists in the Revit model. It has to have the class marker family. If you remember, that's the red sphere that we copied around to show the classes locations. I have already loaded it into here. So let's see if I go to component. That's the class marker there. This is from an external family I have loaded into the model, but don't worry, if you haven't got something you can use, just follow a link in this video description to download this family and then use it straight away. Essentially, it's nothing more than just a solid sphere with a red transparent material. So we can still see everything behind it, like this. Okay, let's make a note now of its family name. The family name is class marker. So we can now go back to Dynamo and define the family type here using family types. This is an input node where you can select class marker from the list. It's there. If you don't see the name class marker or the name of your custom family you want to use, make sure the family is loaded into the model. Otherwise, the name here wouldn't show up. Alright, so at this point, we have all the inputs we need for the next step. We have the coordinates of the classes. We have the family we want to use to mark them in Revit. And also we have the class names coming out from this node there. Now, to start placing the markers, we can use a bit of Python to make the process as efficient as possible. Let's drop in here a Python script node. For now, I will do Python script from string. And now we give it a few inputs. So let's do for x, y, and z, followed by the family type. Now, it's the usual thing I normally do in my tutorials. Let's make now a way for Dynamo to read a text file that contains a Python script We can then use the text from that file as a script input for this node here, and then it will just run the Python script that we have in the text file. All right, let's start giving this Python script node here the script file that it needs. Let's do another file path node, and then select a Python script file I will use just in a minute. That is called test.py. And then similarly to before, we can do file from path. But this time, instead of read Excel, we just do read file as text. That will give us a string. I cannot connect the string to here. And now the next step, we will go into Visual Studio Code, my favorite Python script editor for Dynamo. If you are new to this kind of workflow, don't worry. Just go down to this video description and use a link there to see my basic video tutorial on how to script things in Dynamo this way. It will also show you how to set up and use Visual Studio Code, because this is really the best editor you can have for writing Python script to use later in Dynamo. The video will also show you step by step how to create and understand and use this Python script template that I have opened already. So that should give you all the information you need to then come back to this video and follow me from here. Okay, let's start scripting here. To begin, we need to get the project location from the active model. So let's call this one project location and say that should be doc.active project location. Next thing to do, we need to get the position of the internal Revit origin point in this shared coordinate system, which is what this command returns here. It returns the current active shared coordinate system being used in your Revit model. So to get the position of the Revit origin point in this shared coordinate system, we should call position equals to project location dot get project location, and the origin point will be at xyz dot 0. Let me show you what that means. If I now go back here and then turn on side components, which are project base points and internal origin point. Let's see where they are. Okay, so this one is actually not overlapping the internal origin, which is there. Let me move it there. Let me change these two values to 0 and 0. And now you see actually the origin point in this case is not where the model origin point is. As you can see over here, we have the Revit model 000 origin point. This 000 point is different. This is the origin point of the shared coordinate system. So now if I try instead to move this point to where the model origin point is, you can see now it has some x and y coordinate values. And these values are the ones we are trying to get using this command here. Essentially, we are saying, yes, we understand that the Revit origin point, which is xyz000, it will have all three coordinates equals to 0 in the context of this Revit modeling space alone. However, a shared coordinate system, especially once you have set it up to connect different Revit files and Revit links, it has a different origin point. And we saw that point previously when I tried to move the base point to 0, 0 by changing the northern and eastern coordinates here. We saw clearly it's not the same point as the origin point. So here we are trying to get the coordinates of the Revit modeling space origin point in the shared coordinate system. You will see in a minute why we need it, but that's the first step we need to do here. Okay, next step, let's bring in the inputs from Dynamo into Python. So let's see what we have here. We have X, Y, and Z as input 0, 1, and 2. Let's define that here now. We can say X coordinates equals to input 0. And then if I do the same for Y and Z, I should then change the number here to 1 and 2. The next input we have was family type. So let's say farm type should be input number 3. Exactly as it shows in the Dynamo graph. However, with family type, we need to do something extra. We need to call unwrap element and I will convert a Dynamo object into a Revit object. We need the family type to be a pure Revit object so we can use it later on in creating the class marker instances. Whereas if we just use in-tree alone, that won't work because in-tree is actually the Dynamo wrapper around the actual pure Revit family type object. Next step, we need a way to convert the X, Y, and Z coordinates here from millimeters to Revit internal units. Remember, we got the coordinates from Excel and we checked in Navisworks that these are millimeter values. That's fine to see in meetings and Revit windows, but for using them to create Revit object, we need to use the internal Revit unit system. So now we need to have a way to convert these values to feet and inches. The good news is I have defined that function for you already. So let me just paste it to here. Essentially, this function is called length to millimeter, and it simply check the Revit version. If it's greater than Revit version 2021, then it's going to use this method for converting the value from millimeters to the internal unit. Otherwise, it will use an older unit conversion method in the Revit versions before 21, but still it does the same thing of converting millimeter values to the internal unit value. So with that definition in place, I can now go down here and say I want to have X values. This will be in the internal unit. And I can say length from millimeters. Actually, this name is wrong. Let me change it first. Well, that reminds me that this method needs to have a counterpart. So instead of converting from internal unit to millimeter, I actually need to go the other way around. So let's say from millimeter there. This method will convert from millimeter to internal unit. And this one will convert from internal unit to millimeter. Very easy to get confused there. But anyway, with this one, we can say convert to internal units. And the same here. Okay, and now I can call length from mm down here on the value. And that value will be from X coordinates. So here we have a quick way to construct a for loop. We're looping through value in the X coordinates list up there. And for each value, we convert that into the internal unit from millimeter to internal. Let's do the same now for Y and then Z. Make sure to change the name here at the end too to Y and Z coordinates. Let's now double check the output. So I will now save this, go to here and run this. Oops, there's an error because I used the wrong method name. Let's go here. This method name is wrong. Let's change that to position, not location. And run this again. Now that's working. I can see these are the internal unit values corresponding to the X coordinates in millimeters from my Excel file. So we're good to go. Next step, we can start creating the transaction for generating the class markers in Revit. Before doing that, I need to make sure all the other transactions in the model have been closed using this statement here. This is something available from Dynamo. It makes sure that any transaction still open will be closed, even forcefully if needed. So with that done, I can then start a new transaction myself using with transaction on this active Revit document of the name, let's say, generate class markers. And say that will be stored in a variable called CR. I can now start CR. And also, don't forget, I need to also commit it at the end. Now, within the context of the transaction, I can do certain changes to the model. For example, I can do family type dot activate. This is because sometimes a family type is not activated, and that means it cannot be used for making Revit elements. We need to now activate it first to make sure that's available. Next step, I can open a for loop here. Let's do for X, Y, and Z values from the other three lists that we defined previously. That would be X values, Y values, and of course then Z values. So here we simply use the zip method to loop through all these three lists up here at the same time. and store their current values into X, Y, and Z. That means I can now say point. This will be the location point of my marker. This point will be defined as a new X, Y, and Z object from the X, Y, and Z value in my loop. But that's not enough. We need to also subtract the X, Y, and Z values of this new location point by the X, Y, and Z coordinates of the internal origin point in Revit. So let's call it origin for now. We haven't defined origin yet, so let's do it now. Let's go back up here. So here, remember, we have the X, Y, and Z coordinates of the internal Revit origin points in the shared coordinate system. However, the origin point is X, Y, and Z values are still stored in this single variable called position. So let's say X origin equals to position dot east west. That's simply to say we want to get the property that is east west here, or E/W in Revit. That will be the equivalent of the X value of this point. The Y value we can get from the north-south property of the same point here. So going back now to Python, I can do Y origin will be position dot north-south. And then Z origin will simply be the elevation of the position point. So we can say position dot elevation. I can now create the origin point object as a new X, Y, and Z instance. And I will take X origin, Y origin, and then Z origin as its required coordinates. You can see now that is now defined, which means I can use it here. However, there's something we haven't done. We haven't taken into account the angle to true north value. In this case, that's 30 degrees. That value I can also get from the position object. So let's say angle to north or to true north to make it extra clear here. That should be position dot angle. The reason for getting this is that after we created this point here, even though it has the right coordinates in relation to the origin point, this one here, we still need to rotate it using the angle to true north to make sure this origin point will be exactly where the class point is. To do so, to rotate the point around an origin point or an axis, in other words, we need to create something called a transform. For the transform to be defined, I need to firstly create a rotation axis for it. So let's say axis should be line.createBound. Simply a way to make a line between 2 points. The first point will be, of course, the origin point we have made. And then we need to have a point directly above it, just so the axis line will be vertical. I can quickly do that by using origin plus x, y, and z dot basis z. Basis z is simply x, y, z 0, 0, 1. So this point here will be exactly 1 unit above the origin point. And then by connecting these 2 points, we have a line that is perfectly vertical, even though it will be a very short line. That's fine. And then we can define the transform. Let's call it rotation. Transform. And we can say that will be transform dot create rotation. For the axis of the rotation, I can do xyz dot basis z. And the angle will be, of course, the angle to true north that we have obtained up here. Now, with the rotation transform object ready, I can use it down here to rotate my point. Let's do rotation transform dot off point and supply the point we have made on the previous line. Of course, after rotating the point, we also need to reassign the new point to the previous variable. So let's do it like this. Just so this point here will actually get the new value that should come out from rotating it. Okay, so now with the location point ready, we can start creating the class marker. Let's call it element for element and say doc.create.new family instance. Now we need to supply the location point that we have now, followed by the family type, and then followed by structural type. Structural type is just a way to say if the family will be a structural element. To get it, we need to import the structure namespace that we have done up there. Let's now go down here and say structural type dot non-structural, because obviously the class marker is not a structural element. Finally, we can append that element to the watch list just because I want to see them at the end outside of the node, so I know exactly how many items have been created during this process. Okay, let's now save this. Go back to Dynamo now and run it. Wow, that works on first try. It's really good. Let's see what it has created here. So, lot of glass markers, but seemingly in the wrong place. We know the location works because they seem to be relatively in the same kind of position together. So the thing that's gone wrong must be the angle. Let's go back to Python now. And I have a feeling, just from experience, that the angle probably needs to be flipped. So now instead of position angle, let's put a minus here. So we rotate the objects using the same axis, but in the opposite direction. So we're gonna save it and test it out. Now that has worked, I know, because I can see the bubbles or the spheres inside the building now, but it didn't clear out the previously created spheres, so let's undo twice. You can see there are two directions there with the same name. Now the model is clear one more time. I can now close the script, go back to it, and rerun it. Oops, something's wrong at the beginning there. So the error is here. This node was asked to convert a non-convertible type. Let's see what that has done to here. So you can see there's a no value, and that's where the trouble is. The no value is at index 2, and that's number 9. So here it's trying to convert a number to a string just so we can do the start with check, and that won't work. So we need to somehow make sure in this list here we only have string. Maybe we need to do string from object first. Like so. So instead of going directly from here to there, we need to go through this node, string from object, and run this. Here we go. So that fixes it. And the good thing is now we have all the classes inside the building. That's a good sign. Anyway, that's one last thing that we missed. We didn't assign the class names from this list here to the spheres. So let's do set parameter by name. The value will obviously be these names. Parameter name, let's try to comments for now. Of course, feel free to use your own parameter name, but the name should be from a text parameter for it to work safely. And now we can get the list of items created by this Python node, like this. Let's try it now. So that's done it. I can now go and check in the model. If I now select this sphere, for example, that's right on where the class is. Very nice. And I can see the name is class 11. That means I can now go back to Navisworks, open class detective, go to result, and see class 11. Class 11 is this one. And of course, as you can see in the background there, this class is exactly the same thing I am seeing now in the model. It's right there. Very nice. Last thing to do is to make sure we don't rely on this Python script text to make the script work. So let me go here and do Control A, Control C to copy. Back to Dynamo. I can now drop in here a proper Python script node. So this one. Double click to open it and paste it here. Now I can replace this one with this new node. Let's make sure all the inputs match. So transfer them like this, including the family type. And then of course we need the items to go into set element parameter by name. I can now delete these nodes there and use this single one from now. Let's double check. I will save the script, undo the transaction in the model, and now see if it works still. Let's run this. and it's done it. Anyway, while on the topic of seeing clashes in Revit and Navisworks, just so you know, there's also a good way to see them in Navisworks too, because usually the reason we want to go back to Revit is to have a clearer view of the context of the clash. For example, in Navisworks here, if you have a big building with billions of items, it will be super hard to see a class like this in the context of other elements surrounding it. So one way to do that is go back to Revit using the Dynamo script we built today and inspect the class markers to see the context better. But if you, however, want to stay in Navisworks for this task, there's another way, which is much quicker. You can also just use a plugin for Navisworks called RV Glassbox. If I now go to the RV Boost panel, it's right there. Let's open it. So here I have the same class that I can see from Class Detective. That's one there. If I now select it and click on Generate Views, it has very quickly generated for me all the views that show the context of each and every class. All of them are now saved under Saved Viewpoints in a folder of the same name as the class. That's one in this case. And now I can go to maybe seeing class 11. So you can see there, that's the same class we are inspecting in Revit just now, in this area there. But now instead of going back to Revit and do all the scripting that could be time consuming at the end, you can just do it in Navisworks using this plugin to see this class here in the context of the coordination model. You can also see other classes like class 19, class 30, and so on. That's a bit quicker, but also in my experience, lighter to use because let's face it, the Revit model will almost always be more heavy to navigate and work with than a Navisworks file. So, just another option for you, which may work better for some of us. If you want to try RV Glassbox, just go down to this video description and use the link there to get your free copy of the app today. Otherwise, if you still prefer to review clashes in Revit, the script here can work to save you a lot of time by generating these class markers in a few seconds. If you want to try this script right now without rebuilding it, just go down to this video description and use another link there to download the script directly and run it on your model. If you, however, want to focus on mastering Python scripting in Dynamo, then check out my full Python course in the video description. If you like this lesson and want more like this every single week, make sure to subscribe to this channel now. For now, have a good day and I'll see you in the next tutorial.